Hello and welcome to this lesson where we're going to set up some blueprint code so that the player can damage and kill the aliens in our project. To do this, we're going to perform a trace. Now you may have heard of the term raycasting. This is the same thing as a trace in Unreal. A trace is going to allow us to retrieve information from the world by drawing a line or a shape between two locations and checking if anything is colliding between these locations. So to perform a trace, we have to provide a start location and an end location. Now there's different shapes we can use for tracing, but we're going to perform a line trace. Our start location for our trace is going to be from the barrel of the player's weapon. Then for the end location, we're going to calculate a location that's way out ahead in front of the player's weapon. Now when we perform the line trace using these locations, the trace will collide with any actor that blocks its path, and all of the information about what the trace hits is contained within the hit result that gets returned on the line trace function. We can query the hit result to find out things like what actor was hit and the world location of the hit. Now the function we're going to use in Blueprints is called line trace by channel. This is what we're going to use instead of spawning projectiles for the weapon. We're going to cause damage to any actor that the trace hits. So let's take a look at setting this up. I'm going to start by removing the alien in the level so he doesn't come up and try to kill us while we're testing and setting up the weapon code. Now let's head into our marine blueprint. We're going to create a new function named weapon trace, and this is going to be an impure function. We're going to call this function in the event graph whenever we fire the weapon. Let's drag it out and call it after we execute start firing weapon. But take note that by executing it here, this means that it's not going to behave like an automatic weapon. As soon as we press the left mouse button, it's just going to fire a single shot. But this is okay for now. We can work with this while we set this up, and then we'll take a look at setting up some automatic fire. Inside this function, we're going to call the line trace by channel function. We're going to get the one called line trace by channel. And we can hook it up to the execution pin, and we'll take a look at creating the start and end locations for the trace in a moment. We're not going to change the trace channel. Visibility is going to work fine for us, and we also don't need to worry about trace complex. Now we can provide actors that the trace can ignore, and usually we would want to ignore the actor that is calling the trace. So for example, the player wouldn't want to block the trace and cause damage to himself. But we can see that the function by default ignores self, so we also don't need to worry about setting up any actors to ignore. We can debug the trace so we can see it visually in the world. Let's turn this on. We're going to change the draw debug type to for duration. This will make the trace visually appear for a few seconds in the level. Okay, so let's figure out where we're going to start our line trace from. We want our line trace to spawn at the end of the weapon, at the same place where we spawn our muzzle flash particle. We can select our muzzle flash particle component in the components list, and we can see it's attached to a socket called muzzle flash, and this socket is a socket on the rifle weapon. We're going to get the rifle. We're going to drag out from the rifle and called get socket location, so we can get the location of a socket in the world. The socket is going to be the muzzle flash socket. That's all one word, and this is going to be our start location. So we're spawning our line trace from the same place that we spawn our muzzle flash on the weapon. We can select all of this, we can right click on it and collapse it down into a function called get weapon trace start location. And this can be a pure const function. And we can hit compile. Now we need to calculate the end location. To do this, we're going to create a new function called get weapon trace end location. And this is also going to be a pure const function. Now to calculate the end location of the trace, we're going to get the start location, and we're going to add this by a vector by dragging out the return value and putting in the plus symbol. Now what do we want to add this by? Well, we want to add it by the direction and the distance we want the weapon to fire in. So to get the direction, we can just call the get control rotation function. Then with the rotator that this returns, we can drag this out and we can find the forward-facing direction by calling the get forward vector function. So this returns the direction that we want to fire the weapon in, and we can multiply this by a float to add the distance. And we can use this as the vector that we add to the trace start location. Instead of hard coding in the distance as a magic number, we're going to promote this to a variable called weapon range. So we can easily choose the range of the weapon. I'm going to hit compile and set the default value to something large like 5,000 units. Okay, now all we need to do is return this calculation as a value on our function. So we can add a return node, and then we can drag and drop this pin onto the return node. Okay, so this is actually our function complete now. We can hit compile and save, and we can come back to our weapon trace function, and we can now get our weapon trace end location and use it as the end location for our trace. So now let's come back to our level, and let's just drag in a cube into the level and scale it up a bit so we have something to shoot. And now when we play the game, you'll notice that when we fire the weapon, we are now performing our line trace, and we can see the debug preview. The trace fires in the direction that the player is facing in, and we can even see that it collides against the wall that we placed in the level. So our weapon trace is now working. But we want this trace to start causing damage to the aliens. But first, we need to make sure that the alien has health, and the health decreases when it takes damage. Pause here and create a health variable for your alien class, and remember to set the default value of the alien's health. Then implement the any damage event. Create a function that decreases the alien's health. Decrease the alien's health by the amount of damage being applied, and remember you should clamp the health after you decrease it. Then just for now, if the alien runs out of health, call destroy actor to remove the alien from the level, so it should be super obvious while we're testing if we've killed the alien. So pause here and set all of this up for your alien class, and remember we've covered all of this in the previous lesson, so if you get stuck, check out how we handle damage in the Marine blueprint. Okay, so inside my alien blueprint I've created a new health variable for the alien. Whenever the alien receives damage, we decrease its health, and then if the health is equal to 0, we remove the alien from the level. Awesome, so hopefully you've implemented the health and damage system to your alien too. Now let's come back to our Marine blueprint so we can handle damaging actors when they are hit by the weapon trace. All the information about what the trace has hit is contained within this out hit pin. This is the hit result. We can drag this out and select break hit result to see all the details, and we can see that there's a lot of information here. Right now we only care about if the trace hit was successful, meaning if the trace hit anything in the world. And if it did hit something, we want to apply damage to the actor that was hit. So you'll notice on the line trace by channel function, we have this boolean return value. And on the hit result, we also have a boolean called blocking hit. These are actually both the same thing. They tell us if the trace hit anything in the world. So we can use a branch with either one of these, and we can hook up the execution pin. Then we can drag out from the pin that contains the actor that was hit by the trace, and we can type in apply damage. So if the trace hit anything, we can then apply damage to the hit actor. We can promote the base damage to a variable, and we can name this damage per shot. So we can now tune how much damage each weapon shot applies. We can hit compile and set the default value. I'm going to cause 25 damage per shot. Alright, so let's come back to our level. We can remove this cube, and we can drag in the alien so we can test shooting it. You'll notice if we hit play and start shooting towards the alien, our trace hits are just going straight past it and we aren't actually causing any damage. This is because of the default collision settings of Unreal's character class. By default, the character class ignores trace hits. So we're going to enter our alien blueprint, we're going to enter the viewport, and we need to remember that the alien doesn't have much height on it, so the player will most likely just shoot over the top of the mesh. But this is okay because our issue is not really going to be noticeable from a top-down perspective. The issue we have is that all the components in the character class are set up to ignore traces. We're going to make it so our trace collides with the collision capsule component. So we'll select the capsule, we'll scroll down on the details panel, and we're going to expand the collision preset. We can see that the pawn collision preset is set up to ignore the visibility trace channel. So to fix this, we're going to drop down the collision preset and we're going to select custom. And we're simply going to change the trace response for visibility from ignore to block. And now we can hit compile and save. We can come back to the level and hit play. We can shoot the alien, and now our traces are hitting and we're causing damage, and when the alien runs out of health, we destroy and remove it from the level. Alright, so in the next lesson, we're going to spice up the alien's death with a couple of effects, and we're also going to make it play its death animation. Hey, and welcome to this lesson where we're going to spice up the alien's death with sound effects and an animation. But before we get to this, we want to make sure that our weapon traces continuously execute while we are firing the weapon. So let's come to our marine blueprint, and let's look at the logic where we fire our weapon. We're going to move our weapon trace function inside start firing weapon. We're going to put this on the end of the start firing weapon code. So we can drag out weapon trace and just call it on the end of this code. So when we start firing the weapon, we execute a single weapon trace, but we want to continuously execute the weapon trace function until we stop firing. To do this, we're going to set a timer. A timer is going to allow us to execute a function after a set amount of time. We're going to use a function in blueprints called setTimerByFunctionName. We have to provide the function name, the time it takes until the function executes, and with timers we can choose if the timer loops. So this is going to be perfect for us to loop our weapon trace function while we're firing. Inside our start firing weapon function, after we call weapon trace, we're going to call setTimerByFunctionName. We're going to hook this up to the execution pin. We don't need to provide anything for the object pin. When we hover over this, it says it defaults to self. This means that it's going to look inside this blueprint with a function of the same name that we provide. The function name is going to be weapon trace. So we're going to set a timer on our weapon trace function. But the time is going to be our weapon fire rate. We can right click on this pin and promote it to a variable called weapon fire rate. I'm going to set my weapon fire rate to be 0.08 seconds, which should give us a nice automatic weapon feel. And we want to make sure that we loop our timer. So let's try this now. Let's come back to our level and let's hit play. And if we start firing once, you'll notice that the trace is continuously executing now. So we need to make it when we stop firing the weapon, we stop firing our trace. So back inside our marine blueprint, we can come to the event graph and let's enter the stop firing weapon function. Before we check if the player is alive and we spawn our rifle and Q, we're just simply going to call the function named clearTimerByFunctionName. This function is going to allow us to remove our timer on our weapon trace function. So now let's try this again. Let's come back to the level and hit play. If we start firing, we're spawning weapon traces. When we stop firing, we are no longer executing our weapon traces. Awesome, so our weapon is acting like a fully automatic weapon now. So this is good. So our next step is to make our alien death more convincing. Head inside your alien AI blueprint and create a variable that stores if the alien is dead. Then create a new function called killAI. Inside this function, set the alien as dead and call the function we created called deactivateAIMovement. So when we call killAI, we set them as dead and stop the AI's movement. Once you've done all this, call the killAI function when the alien runs out of health. Okay, so inside your alien blueprint, you should now have a variable that we can use to store if the alien is dead. And you should have also created a new function called killAI, and we call this after the AI runs out of health. We're going to kill the AI, then add a delay, and then destroy the actor. So once the AI is killed, we delay by, let's say, 3 seconds, and then we remove the AI from the level. Now inside the killAI function, we set the alien as dead, and we deactivate their ability to move. Now when the alien dies, we want to disable its collision, so it's not going to block anything in the world. To do this, we can call the setActorEnableCollision function. We're going to hook this up with the execution flow, and we're going to make sure that the checkbox is unchecked. So now when we kill the alien, we set it as dead and we disable its ability to move and we stop it from colliding with anything in the world. Now let's make it so the alien plays a death animation when we kill it. Let's come back to the content browser and to the characters folder, and let's open up the animation blueprints for the alien. In the events graph, when the animation updates, we calculate the movement speed and we store it. Just next to where we do this, we are going to call the reference to the alien blueprint. We're going to get the dead variable from this, and we're going to store it as a variable inside the animation blueprint, so we can actually call this inside our anim graph. Okay, so we're now storing if the alien is dead. So let's hit compile and let's switch over to the anim graph. We could add a death state to the state machine, but I'm going to show you one other way we could approach this. This way will also make sure that the attack montage can't be played on top of the death animation. We can grab our dead variable. Let me just cancel this autosave, and we're going to move these nodes down here as well. We're going to drag out the dead variable and type in blend. We're going to get the node called blend poses by bool. This allows us to switch between different states or animations depending on the condition. So if the alien is not dead, we can allow our state machine and attack montage to play. We'll hook this up to the final result as well. But if the alien is dead, we can come to the asset browser, we can grab the death animation, and we can play the death animation if the alien is dead. And we also want to make sure that we do not loop the death animation. So we're going to select it, and we're going to uncheck loop animation on the details panel. Okay, so now the alien's animation blueprint is set up to play the death animation. You'll notice if we play the game now, when we kill the alien, it plays its death animation, and then after a few seconds it will disappear from the level. Awesome, so it's getting more convincing now. We can spice up the alien's death a bit by playing a sound effect when the alien dies. Inside the sounds folder, we have this Foley Flesh folder. We can come inside the mono folder, and there's some gruesome sounds that we can use for our alien's death here. And there's already an audio cue set up that we can use. We're going to use this Foley Flesh Gib cue. We just need to make sure that the mixer is connected to the final sound output. And we can play it just to preview it. And we can hear that this is going to sound pretty good for our alien death. Now we're going to spawn this as an anim notify when the death animation plays. Let's come back to the characters folder, inside the spider folder, inside the animations, and we're going to open up the death animation, whichever one the death one is. It's here. We can pause the animation, and at any point during this animation we can spawn this sound. We might as well just spawn it right near the beginning. So on the notifies bar, we can right click, we can come to add notify, and we can select play sound. We can select the play sound notify, and in the details panel on the top right we can assign a sound here. So the sound was Foley Flesh Gib. If we scroll down there should be a cue for it, and here it is. Okay, now if we play the animation, we can see it plays the sound with it. Awesome, so we can save the asset, we can close it, and let's try killing the alien now. Okay, awesome. So the alien's death is looking and sounding pretty convincing now. Remember, we have our kill counter on the player's HUD. This is bound to the variable called kills inside the Marine blueprint. Now I'm going to challenge you to set up some code to make the kills increase when the alien dies. Inside your Marine blueprint, create a new function called increase kills. Within this function, you simply want to increment the Marine's variable named kills. Then within your alien blueprint, call the Marine's increase kills function from within the alien's kill AI function. So whenever an alien gets killed, the kill counter will increase. And it's already bound on the player's HUD, so we should see this working immediately. So pause here to set up the kill counter. Okay, so I hope you had a go at setting this up. To do this, we're going to head inside the Marine blueprint. We're going to create a new function called increase kills. Within this function, we're going to get the variable that's named kills. We're going to drag this out, and we want to add 1 to this. So every time we call increase kills, we just increase the kills by 1. To do this, we can just put in the plus symbol, and we can call increment int. So this takes the kills and adds 1 to it and sets it for us, and we can hook this up to the execution pin. So that's our increase kills function complete. It's very simple. Now inside the alien blueprint, we want to call this whenever the alien dies. And at the moment, whenever the alien dies, we call the kill AI function. So within this function, we're going to right click and get the player character. And we can cast the player character to our marine blueprint, which allows us to access the functions of the marine with this reference pin here. We can drag this out and we can call increase kills. So now whenever an alien gets killed, we set it as dead, we deactivate its movement, disable its collision, and then increase the player's kills. Awesome, so let's hit compile and save, and let's come back to the level and let's try this out. So if we kill this alien now, we can see the kill counter is updating. We can actually select the aliens now and we can hold down left alt and click and drag so we can spawn multiple aliens. And we can see that with each kill, the kill counter on the player's HUD is updating. Great, so this is feeling like it's really coming together, but there's a few loose ends that we need to tie up in our code before we go any further. With all of the code in the event graph for the alien blueprint, we're not checking if the alien is dead or alive. We only want to execute our code if the alien is alive. So I want you to pause here and create a function that returns if the alien is alive, just like we did with the marine blueprint. Then only executes the AI movement code, the attack code, and the damage code in the event graph if the alien is alive. So pause here for this final challenge. Okay, so you should have a function that returns if the alien is alive, and this should be a pure const function. Inside the event graph for the alien blueprint, we should check if the alien is alive before we execute any of the code that makes the AI move towards the player. And we want to double check that when the AI succeeds or fails in moving towards the player, after we delay by 0.2 seconds, we want to make sure that we definitely do check again if the alien is alive. And when we damage the alien, we can also check if the alien is alive before we decrease its health and then go ahead and kill the AI if it has no health remaining. Then finally, we have the code that runs on the tick event. We have a condition that checks if the alien is within the attack range and if it's not already attacking. If this condition is met, then we can play the attack montage. But we want to expand this condition to take into the account if the alien is alive. We can add an additional pin on the AND node, then we can plug the isAlive function into the input. Now we can select all of these nodes and we can collapse these down into a function named canAttack. And this can be a pure const function. So that just makes that a bit neater there as well. Okay, so we now check if the alien is alive before we execute any of its core behavior. Now there's one more place we want to check if the alien is alive. It's inside the damage player function. I've already added the code here, but you want to check if the alien is alive before it goes ahead and damages the player. Okay, awesome. Now once you've done this, we can switch back over to the marine blueprint. The marine already has a function that returns if he's alive or not. We use this to disable the movement input and the weapon input if the player dies. But we can also use this when the marine gets damaged, because there's no point executing any of the decrease health functions and killing the player functions if the marine is already dead. All of these checks may seem unnecessary, but by adding them in, we're going to eliminate any bugs with the AI killing the player after the AI has been killed themselves. Now there's one more bug I've noticed that we can fix before we end this lesson. If you kill any aliens, you'll notice if you run around them, they will keep snapping towards the player as they are dying or as they lay dead. Luckily, this one's a really easy fix. Within the alien blueprint, when the alien runs out of health, we call the kill AI function. Inside this function, we call the deactivate AI movement. We deactivate its movement, but if it's still moving towards a target, it won't stop looking towards the location where it's moving. So to fix this, we're going to drag out from the character movement component, and we're going to call stop movement immediately before we deactivate its movement. So this will just fix that little issue we see now. You'll notice if you come back to the level and kill your aliens, they are no longer rotating around towards the player. Okay, so that wraps up this lesson. Our weapon now runs on a timer, we fixed some bugs, and the alien's death is a lot more convincing now. In the next lesson, we're going to start looking at how we can spawn the AI in waves.